Hey everybody, welcome. It is Thursday, March 26, 2020, and it is my birthday. So happy birthday to me. You can send all of my gifts and money just directly to the school. Don't worry, I'll get it eventually. Um, so yeah, I know you're probably worried about that. We are in Chapter 3 still, exploring wind and pressure. We're in 3.2 today, analyzing data about storms. Our Chapter 3 question has not changed. Why did the most recent storm in Galetown have the greatest amount of rain? And our investigation question is also the same. How can wind affect the cooling of an air parcel? Our vocabulary word today is source, where something comes from. And that will make sense as we get further into today's lesson. But before we get into today's lesson, let's look at yesterday's lesson, actually. I want to look at activity 3 with you. You were in the simulation, and you were supposed to create different amounts of wind and see how they affected the eventual storm that came about. And ultimately, what we should have found out for like the first question up here, ding, it says use your data table to describe how wind can affect the cooling of an air parcel. Well, down here in our data table, we saw parcel 1 where we had wind. Our final air temperature parcel was negative 40 degrees. Parcel 2, where there was absolutely no wind, our final air temperature of our air parcel was negative 25 degrees. So clearly the one with more wind had a cooler temperature. Now, your data might be a little bit different depending on how much wind you created. But ultimately, this is what we should have seen, that an air parcel that was affected by wind would end up having a lower temperature than one that was not affected by wind. So how does wind affect the amount of rain? That's the second question there. And what we should have seen was, well, since that air parcel is cooling that much more, there's going to be more condensation for the amount of water vapor that's in that air parcel. So the more condensation you have, the more water turning from gas to a liquid, the more potential rain you would get from that situation. For the homework, it was a reading about different types of rain. We had orographic rain and frontal rain. And there was 3 questions to answer there. The first was, what type of rain do you think you normally experience? Well, what type do you think you normally experience? Our orographic rain was where the air parcel is forced upward by a geographic feature like a mountain. And since it's being forced upward, it's going to cool off more because it is rising higher in the atmosphere. The higher you go in the troposphere, the colder it gets. And so we're going to see more condensation and more rain. The frontal rain, however, is something that we actually talked a lot more about last year, but we haven't talked about it much this year. But where you have 2 air parcels of varying temperature, pressure, humidity that meet one another. And at the point where they meet, one air parcel basically is forcing another one to go higher into the atmosphere. Typically, where you'll see the biggest storms is where you have a cold air parcel that forces its way underneath a warm air parcel. And that warm air parcel, as it rises higher in the atmosphere, you know what it's going to do. It's going to cool off. The water vapor is going to condense. And we're going to see quite a bit of rain from that type of front. So let's go ahead and jump into today's lesson. 3.2, I'm going to go ahead and read because I love doing that. The introduction for our lesson to find out where we're going. It says, today, you'll look at weather data from several storms around the world to figure out if the severe rainfall in each storm was caused by a change in temperature, water vapor, or wind. You will also learn more about how scientists think about the sources where they get their data before deciding if they actually want to use and trust that data. Such an important thing. We get data from all sorts of sources. I mean, look at what's going on right now. There's data coming in from so many places. What data can you actually trust? Well, that's a great question. What data can you trust? Because you might be getting information that's telling you different things, like don't touch your face, like I just did. Which, yeah, you don't want to touch your face. But anyways, let's go ahead and take a look at our warm-up. Again, we're in lesson 3.2. So here is our warm-up. Below are 2 descriptions, are descriptions of 2 different groups or sources that collected data about birds. How nice. I love hearing all the birds singing so happily outside of my window. Read about both sources, then answer the questions below. Source 1. A blog written by a hiking club. That sounds fantastic, where club members regularly report the number of different birds they see. Source 2, an article in a science journal where biologists report observations they collected about birds during a research study. So the question here is, which of these sources do you think would be able to give you better evidence, higher quality evidence, and why do you think that? So I'm going to go ahead and say hit pause and then answer that question. Pause. Welcome back. What did you say? If you said source number 2, well, I agree with you. Now, source number 1, it's not that these people don't know their birds. It's not that they, wouldn't be able to identify them or that they're bad at counting. It's just that source 2, we would definitely consider a more reliable source. Source number 2, an article in the science journal. That means that a lot of scientists have probably read this, have evaluated it for themselves, have critiqued it, given their own feedback on it. So it's not just one person saying, oh, I saw a blue jay the other day, but it's a whole community of people who are fact checking this information that's going into the science journal. So here's what we are going to do next. Let's click on number 2. Student to student discussion. We have evidence cards. Basically, for number 2, what you're going to be doing is you're going to be evaluating sources of evidence. You're not going to be evaluating the evidence itself. You're evaluating the source of the evidence. So I have attached to your assignment our evidence cards. Now, these are unfortunately formatted for printing, not for viewing online. So it's a little bit funky, but we'll work through it. You want to look at side 1 of all of these evidence cards. This is the first thing we're doing. You're going to look at the source. Okay, so you can see the first page, it has side 1 of evidence card A, side 1 of evidence card B. But when you go down to the next page, this is now side 2. Again, only focus on side 1 for all of these cards. What you're going to be doing is you're going to be putting them in order. What do you think is the most reliable piece of evidence based on the source, and which is the least, and what are all the sources in between? So I'm going to give you a minute to do that. And I guess what I would want you to do is actually just write it down somewhere. Take a note. Which evidence card, A, B, C, D, E, F, put them in order of what you think is the most reliable to the least reliable. Do that now. Pause. Here's the next thing you want to do. So you have all of your evidence cards sorted. What I want you to do is go back to the Google Classroom to today's lesson, and I've posted a question there. It should say Weather Patterns 3.2, Activity 2, and it has the questions for this. And what I want you to do is respond to those questions. Let me pull them up right. I can't pull them up right now. Respond to those questions and read some responses of other students. And you can, if you want to, reply to some of those responses from other students or not, but definitely read them and check them against your own response. Go ahead and do that right now. Pause. And now for activity 3. So we have evaluated each of our pieces of evidence, and we've said that which ones we think are more reliable, which ones we think are less reliable. What I want you to do is the ones that you think are reliable, we're going to focus on those right now. The ones that you think are maybe less reliable, go ahead and just set those aside. So for this part, it says read and discuss side 2 now for all of the cards that you have left, all of the reliable cards. So read all of that evidence. And let's answer these questions. What do all of the big storms have in common? In which storm do you think the most energy was transferred and why? Now, again, I've posted this question for us to answer in our Google Classroom. So look for Weather Patterns 3.2, Activity 3, and you will find these questions. And just like we did in the previous activity, respond to the question, read other responses from other students, and so go ahead. Read the evidence, answer those questions. Do that now. Pause. And welcome back. I hope you had some thoughtful responses to those questions. Now, did you notice this? I was looking at evidence card F, and I noticed that it was talking about pressure. It didn't say anything about wind, but I wonder, can we apply our understanding of wind and maybe some of the definition of wind, air moving from areas of higher pressure to areas of low pressure? Can we figure out what might be going on here on this slide? Card F, yeah. Hopefully you're able to put some of that together. And if not, I would challenge you to go back and take a look at that and see if you can apply some principles of what we know about wind and pressure to that situation. So, here we go. Next thing we're going to do is move on to the homework, and there's two things that you need to do. The first one is we're looking back at that article in just this paragraph right here that's talking about the sources for the information that we got about the Great Flood that happened back in the 1800s in California. And it's asking, hey, what do you think, right here, are the most reliable scientific sources based on where this information came from, and why do you think that is? And then the next part, which are the least reliable scientific sources, and why do you think that is? So look back at that article, just that one paragraph, and examine those sources. And then the second thing is this reading that we have, how we predict the weather. And you're going to read this article, pretty short, and answer a couple questions down at the bottom here. Different tools that modern meteorologists use to predict the weather, and why are meteorologists' weather predictions sometimes wrong? I'm sure we've all noticed that before and experienced that before. It's not that they're bad at their job, it's something else. So look forward to reading your responses there, and we'll talk more about that next time we meet. So until next time.